Okay, so now we're going to talk about multivariate linear systems. So these are just systems of equations. They're still linear, which means all the variables are going to have exponents of 1, but in this case, we're going to have more than two variables. We may have three variables, and then we'll have three equations, or we might have four variables and four equations. Okay, so let's look at our examples here. First off, we're going to just look at some simple ones, and this is called back substitution. When in what's called echelon form. Now, this is going to talk about things called row echelon forms in this section, and I'm not going to go through a lot of detail on how to determine that, because that's really more reserved for the next set of videos when we're going to talk about matrices. But this kind of leads us into why we want to develop something like matrices. So I'll give you a system of equations that is in echelon form, or row echelon form. When I say echelon form, I should put a parenthesis here. It's really row echelon form. Plus, so I have 2x minus y plus 5z equals 22. And then I've got y plus 3z equals 6. And then I have z equals 3. And this is row echelon form, and I like to kind of indicate it is that there's like a little bit of stair stepping going on here. You know, you can kind of think about it as you can kind of form a set of stairs here. And the first equation has three variables, the second equation only has two, and it's the x one that's gone, and the third equation just has the z variable. So we want to find the solution here. Well, right off the bat, this is easy. We know that z equals 3. So I've got part of my solution, you know, because I'm going to have a solution with three numbers for x, y, and z. And then I'm just going to do back substitution, which means I'm going to take this, substitute it into the previous equation. So then I have y plus 3 times 3 equals 6. So y plus 6 is equal to, hello, let me try that again. 3 times 3 is 9. So y plus 9 is equal to 6. And y is equal to negative 3. And now we do one more back substitution, and we substitute it back into the top equation, which would be then 2x minus negative 3 plus 5 times z, which is 3. And this is equal to 22. And so you get 2x plus 3 plus 15 is equal to 22. So 2x plus 18 equals 22. And then 2x is equal to 4. And then you can divide both sides by 2 and of course get x equals 2. Now, we are going to write our solutions as what's referred to as an ordered triplet. Meaning if you were to graph these are graphs in 3 dimensions. And it turns out these graphs, well, some of these are lines and some of them are planes, things like that, but you can plot these in 3 dimensions. So if you plot these in 3 dimensions, the ordered pairs you do, well, it's x, not ordered pairs, ordered triplets, it's x, y, z. So it is important that you write the order down correctly. So the solution here would be 2 negative 3, 3. Alright, so that's all well and good. The problem is that we don't typically have things that are in row echelon form. We typically have to make our systems of equations into row echelon forms. So this is using something called Gaussian elimination. And the key thing here, I'm going to star this, These are operations that we can do that produce equivalent systems. And these are referred to as row operations. Because if you think about each equation being a row, we have 3 rows. So the first thing we can do is interchange two equations. And all that means is I could write the first equation as the third equation, so on and so on. It's one of those things you might, well, why would you ever want to do that? Well, it turns out it's actually a little bit more common than you might think. Okay, so then let's look at what we can do. The second thing is we can multiply one of the equations by a non-zero constant. Well, yeah, we kind of already know that. I can multiply both sides of an equation by a number, doesn't change anything. And then the third thing here is I can add a multiple of one equation to another equation. But this is key here. We replace the latter equation, meaning the second one, with the result. Now we can do these to move things into echelon form, row echelon form. So let's look at a simple example here where it's just a system of 2 equations and 2 unknowns, just to start getting an idea of it here. So I'm going to have the system of equation is 2x plus y equals 3, and then x plus 2y equals 3. So I'm going to go ahead and do one of these where it doesn't necessarily seem obvious that this would help, but I'm going to go ahead and interchange these 2 rows. So I'm going to write this as x plus 2y equals 3 and 2x plus y equals 3. Now you might say that's kind of silly, that was ridiculous, why'd I do that? The main reason is I'm going to, in general, and we'll see this when we move on into matrices, want a 1 if possible up here in the top left. And yeah, there is a 1 there. And so then what I can do here is I can say, well, wait a minute, if I take the top equation, multiply it by -2, I could add it to the bottom equation and get a result eliminated. And what do I mean here? Well, let's do -2 times x plus 2y equals -2 times 3. So this would be -2x minus 4y equals -6. And then what I'm going to do is I have 2x plus y equals 3. I'm going to add these 2 equations together, and so this is going to be 0x, and then I'd have -3y is equal to -3. Now you might say, okay, I know what y is at this point, but I'm showing you row operations here. So I'm going to go ahead and just leave it like that for now. And what I'm going to do is rewrite this equation now, because what row operation did I do here? I did this third one. I added a multiple of one equation to another, and then I replaced the latter equation with the result. And so if I do that, I would end up with the system of x plus 2y equals 3, because I did a constant on the first equation and added it to the second equation. And so then I would be left with negative 3y equals negative 3, which of course now we can just do the whole back substitution. Now I know this is just 2 equations and 2 unknowns, but this is going to be the process that we're going to do for the 3 equations and 3 unknowns. And so if you divide both sides by 3 here, of course we get y equals 1, and then substituting we get 2 plus 2 times 1 equals 3, and so x equals 1. So the solution is 1, 1. Okay, I'm actually going to stop this video here, and it seems like a rather short video, and it is, but the reason I'm going to do that is I want to do like 2 more examples where we have a big system of equations that we have to solve, and I want to actually make it so that we don't have to make this video super long.